today we are going to start. We are going to continue the same topic. That is called what? That is a dilution concept. Very important. Okay. The question will ask based on that method. Just wait, students will join. We can start for 2 minutes. Okay. Please solve the formula. Molar the formula. We know the lambda m equal to kappa into 1000 by molarity. Okay, concentration. Now, what is the unit of lambda m? Anyone? What is the unit of lambda m, students? What is the unit? This one. Anyone? What is the unit of lambda m? Simon, centimeter, square, mole inverse. And same formula in case of meter square different, right? Same lambda m equal to kappa divided by 1000 into m. Okay. For this case, what is the formula? What is the unit now? Simon meter square mole inverse. Okay. This is equivalent molar conductance. Molar conductance. What is the equivalent conductance formula? Lambda EQ same that equal to kappa into 1000 by normality. Okay, normality. What is the formula same for this one? Simon centimeter square equivalent minus 1. Okay. Now what is the one more formula in case of meter square? Equivalent equal to into k into 1000 into n. What is the unit of lambda EQ? Simon meter square equivalent minus 1. Simple. This or no? This is unit. Okay. Now stop. Now we are going to start the topic or variation of conductivity. Okay, please note. Very important topic, basic topic. Note the variation of conductivity. The variation of conductivity, that is kappa, right? Kappa. And molar conductance. And molar conductance with dilution. And molar conductance, please note. And molar conductance with dilution. Just do it. Conductance with dilution. Now note the point. What is lambda m? Now you know what is lambda. This is lambda. This is lambda, right? Lambda m conductance. Lambda m. What is lambda m infinity? Or some people call lambda m naught. Both are same. Lambda m naught. Now what is lambda infinity? Now what is the meaning for this one? Please know this, sir. The molar conductance. Molar conductance at infinite dilution. At infinite dilution. This is lambda infinity. What is lambda m naught? Okay. This is a limiting molar conductance. This limiting molar conductance. Please note. Limiting molar conductance. Okay. Please, first, very important. Please. On increasing dilution. On increasing dilution. Or increasing dilution. Okay, the lambda m, the molar conductance increases. Molar conductance increases. Okay, increases. This point, please note. The strong electrolyte. See the graph. Just wait. Just wait. Screen is visible, students. Please raise your screen is visible. Please raise your hand.
Yes, sir. Yes, visible.
Okay, thank you. Please. Morning. At the point, both K conductivity and molar conductivity increases with dilution. With dilution increase with dilution. Okay, very important. Please note. Next one, பார்த்தோம்னா please note. Here variation of the first one. Variation of conductivity or kappa. The variation of conductivity with ரெண்டு இருக்குல்ல, first you discuss conductivity, then followed by molar conductance. Okay, variation of conductivity with dilution. With dilution. Okay, please note. On dilution, we know very well. On dilution, okay, volume increases. Volume increases. Volume increases. Volume increases. At the same time, what we know very well, right? N by V, right? Constant N by V concentration. Okay, volume increases right now. Concentration decreases. Therefore, concentration decreases. Okay, on dilution, what will happen? Volume increases. Okay, and concentration decreases. Therefore, just wait on. In the point marking here. Okay. The both kappa and lambda m, okay, change with dilution. Change with dilution. What do you change now? It can be increases or it can be decrease. Okay, decrease. Okay. Now we are going to discuss. Okay, what will happen on dilution? What about kappa? What about kappa mean conductivity? And what about the lambda m? Okay, first see the kappa value. On dilution, the volume of solution increases. See, at the same time, concentration decreases. Therefore, on dilution, on dilution, the conductivity kappa, very important. The conductivity of solution, the conductivity of solution decreases. Very important. Okay, what's conductivity mean? Kappa, again telling kappa. Okay, conductance not G, conductivity na kappa. Upon the dilution, the conductivity of solution decrease. Okay, I'm going to discuss. Okay, and decrease at the background. Very simple. Since on dilution, the volume of solution increases. The volume of solution increases. Yes or no? And concentration will decreases. So very important. So the number of ions. So the number of ions per unit volume, very important, per unit volume decreases. You know very well, when number of ion increase ஆச்சுன்னா conductivity increase பண்ணு. What is conductivity அப்படின்னா the conductance of 1 centimeter cube of solution, right? What is conductivity அப்படின்னா this, please note, very important. Already I discussed this one. Note the into, okay? What is conductivity அப்படின்னா the conductance of, it is a conductance of 1 centimeter cube solution. இதுதான் solution is called as conductivity. Is called as conductivity. You got the point? அப்ப என்ன பண்ணா on the dilution, okay, on the dilution volume for example, okay, இப்போ இது எடுத்துக்கியா, இப்போ இதான், இது வந்து அந்த 1 centimeter cube, இது மொத்த பீக்கர், ஓகேவா? இப்போ இந்த 1 centimeter cube பார்த்தா இந்த 1 centimeter cube 10 ions இருக்கு, 10 ions இருக்கு. Now I am going to increase the dilution. Volume increase ஆகும், volume increase ஆயிடுச்சு, volume increases. இப்போ பாத்தீங்கன்னா இந்த சென்டிமீட்டர், ஐ மீன் அதே 1 centimeter cubeல, okay, what will happen? Only the 8 ion will be present. Other ions will be occupied in the position. So the concept புரியுதா? Other position. அப்போ வந்து on the dilution volume increases, it means concentration decreases, so the number of ion per unit volume decreases. We know very well the conductivity directly proportional number of ions, okay? But number of ion decrease ஆச்சுன்னா conductivity almost decreases, okay? Now see, mathematical பார்க்கலாம், okay? ஒரு சின்ன ஒரு எக்ஸாம்பிள் for understanding only. இப்போ 100 ml சொல்யூஷன்ல, okay, I have 50 ions இருக்கு. எவ்வளவு ions இருக்கு? 50 ions. Yes or no? அப்போ 1 ml எவ்வளவு இருக்கும்? 1 ml ல, okay, 5 எடுக்கலாம், okay? எவ்வளவு 500 by 100 500 by 100. அப்போ how many ions இருக்கு? 5 ions இருக்கு. You got the point? அப்போ 100 ml ல 500 ions இருந்தா 1 ml இருக்கும் 500 by 100 5 ions. Similarly, now I am going to increase dilution. What is dilution அப்படின்னா volume increases, therefore I take 400 ml. 400 ml ல எவ்வளவு இருக்கு? 500 ions இருக்கு. Therefore per ml எவ்வளவு இருக்கும்? per ml ல 5/4 ions இருக்குமா? அப்ப வால்யூம் வந்து 100 இருக்கும்போது எவ்வளவு ions இருக்கு? per ml ல 5 ions இருக்கு. Yes or no? அதே வால்யூம் 400 இருக்கும்போது per ml ல 4 ions இருக்கு. அப்ப therefore volume increases, the number of ion per unit volume decreases. இங்க 5/4. What is 5/4? Almost 1/5 வருமா? 1.5 தான். இது 5 ions. அப்ப அந்த 1 ml சொல்யூஷன்ல 5 ions இருக்கு. In case of 100 ml ல. அதே into 1 ml வந்து 5/4 ions இருக்கு. அதான் சொல்றேன். On dilution, volume increases, concentration decreases. So at the same time, the number of ion per unit volume decreases. Therefore, on dilution, the conductivity decreases. Very important, please note. Very, very important, please note. Got it. This is very important. Okay, both strong electrolyte and weak electrolyte have conductivity decreases with dilution. But change இருக்கு. I will change that change. Okay, what change? Okay, please note. For strong electrolyte, for strong electrolyte, okay, the K value decreases rapidly. Very important. This is very meaning. Rapidly decreases. Rapidly will decreases in concentration. புரியுதா? What is concentration decreases now? Dilution increasing dilution. Increasing dilution. Important, please note. Now, rapidly decrease of the now for you take NaCl. It is strong electrolyte, yes or no? They undergo 100% ionization. When I did it, Na plus Cl minus dissociation ஆயிருமா? But due to the 100% ionization, the conductivity of strong electrolyte will be decreases rapidly on increasing dilution. It means what is increased dilution now? It means decreasing concentration. Okay, important, please note. In case of weak electrolyte, That also decreases, but not very gradually decreases. Okay, please note the point. The weak electrolyte for weak electrolyte, the conductivity decreases gradually. Okay, decreases gradually. Gradual decreases. Okay, important, please note. Same. அப்போ வந்து what is the first one? Conductivity kappa value. Kappa வந்து on dilution increases, kappa value decreases தான். Both case. Strong-ஆ இருந்துச்சுன்னா rapid decrease ஆகும். Weak-ஆ இருந்துச்சுன்னா gradual decrease ஆகும். ஓகேவா? Let's go with the second term, that is conductive dilution of it means what? The variation of molar conductivity with dilution. Lambda m பத்தி பார்க்கலாம். Second one, please note. This is variation of the molar, listen, molar conductance same தான், molar conductivity same தான். ஒரு conductivity வேற, conductance வேற. Conductanceனா G, conductivityனா kappa, okay. Molar conductance lambda m தான், molar conductivity lambda m தான், okay. Molar conductance or molar conductivity of the molar conductivity, variation of molar conductivity of with dilution. Very important, please note. See the approach, okay? Approach is different. See. Now we take lambda m. What is the formula? Lambda m is equal to, tell me anyone formula. What is lambda m? In case of centimeter square, what is the formula? Lambda m formula. Anyone?
Sir, kappa 1000
Kappa 1000
by C.
Good.
Concentration.
Kappa
Molality.
into 1000
Kappa
by molarity, okay?
by
molarity.
concentration.
Okay.
Yes.
Got it. Now we know very well, okay? We know very well. On dilution. What about K value? Kappa value. Increases or decreases? Anyone? On dilution, kappa value. Kappa value. Decreases. Good.
Decreases.
At the same time, on dilution, M concentration value. Concentration. Decreases. Decreases. M decreases. But 1 by M increases. Yes or no? Now see, very important. Yes, the lambda m dilution to kappa. Yes or no? The lambda m dilution to kappa. At the same time, the lambda m and dilution 1 by m also, right? Both are right. Now see, on dilution, see two different scenario, okay? On dilution, K value decreases. At the same time, 1 by m value increases. Suppose on the solution of the molar conductance depend upon K இருந்துச்சுனா, okay, now see, their competition. What is competition? K versus 1 by m, okay? Upper on dilution, K value decreases, but 1 by m value increases, right? Yes or no? Now the both are competition. இப்போ இந்த K 1 by m இருக்கு. இப்போ இந்த ரெண்டுல வந்து எது சொல்லுதோ அதுக்கு lambda m கேட்கணும். For assume, okay? இப்போ compared to 1 by m ஓட K அதிகமா இருந்துச்சுனா, what will happen in dilution lambda m? Increase or decrease, students? Tell me. 1 by m factor K factor அதிகமா இருந்துச்சுனா, on dilution what about lambda m என்ன ஆயிரும்? Decreases. Yes or no? You got the point. Suppose K factor 1 by m factor அதிகமா இருந்துச்சுனா, lambda value increases. இப்போ இங்க 2 scenario வருதா? You got the point. But and experimentally, as experimentally compared to K, the 1 by m factor is more dominated. You got the point. But compared to K, the 1 by m factor more dominated. Upon the dilution, okay, the 1 by m factor more increases as compared to K decreases. Therefore, the conductivity, it depends upon 1 by m. Therefore, on dilution, the conductivity increases. You got the point. Understand? Okay. Now what is the point up now? Please note. For the molar conductivity, the molar conductivity, lambda m increases, very important, increases with increasing in dilution, increasing in dilution for both strong electrolyte as well as weak electrolyte. You got the point? Okay. Why this increases? See the point. Now, சொன்ன point statement தரேன். Okay. On dilution, K value decreases, yes or no? But the concentration also decreases. Okay. And decreases. And 1 by m value increases. Yes, or very important. 1 by m versus K value. Okay. Now, experimentally, the increasing 1 by m value, is more dominated as compared to decreasing K value. You got the point. Therefore, on dilution, the 1 by m increases, and finally the lambda m also increases. Very important, please note. You got the point? Upper the molar conductivity and molar conductance increases on dilution in case of strong as well as weak. If you want to study about the molar conductivity of strong electrolyte, we go with the Debye-Huckel-Onsager equation. But unfortunately, we cannot find out the molar conductivity of weak electrolyte directly. Okay, now we can go with the indirect method to predict the molar conductivity of weak electrolyte with Coleridge law. Now we are going to go two approach. Now strong electrolyte, I am going to apply Debye-Huckel-Onsager theorem. Based on that theorem, they tell about the conductivity nature, molar conductivity nature of the strong electrolyte. At the same time, okay, the weak electrolyte, the molar conductance cannot be found out directly. We go with the indirect method, is called Coleridge law. Okay, now see the graph. After graph, we can discuss this. This is the nature of graph. The molar conductance is a root C. In a root C. In a lambda m. Lambda m, lambda, okay, lambda m. Actual graph, okay. I mean, what is actual graph? Right to left the actual graph. Yes or no? Yeah, on dilution. On dilution, and I concentration degree sum of what is this graph we have to study from right to left. Okay. On dilution, I mean on dilution, concentration decreases. At the same time, the molar conductivity increases, right? This is the graph actually. You are said like this, the graph. This is a graph. Okay, understand? Just wait. This is the graph. This is one electrolyte. For strong electrolyte, this graph. This is strong kind of graph. See, this is strong electrolyte. Okay. This is for, please note, this is for weak electrolyte. Now this is for which one? Strong. இப்போ இதுல இப்போ வேல்யூ வந்து 10 ஓகே 10 வச்சுக்கலாம். இது 10. Decrease 0 வா? அப்ப இந்த பாயிண்ட் what is this point indicate what? The concentration sees approach near to 0 வா? It means what? Infinite dilution. Yes or no? What is infinite dilution now? Very, very, very dilute. If in case of see the weak electrolyte, if I go into extrapolate this graph, நான் எக்ஸ்ட்ராபுலேட் பண்ணேன் டச் ஆகாதா இப்போ டேட்டா மேலேயே போயினே இருக்கும் எஸ் ஆர் நோ இப்போ இன் கேஸ் ஆஃப் ஸ்ட்ராங் எலக்ட்ரோலைட் ஓகே ஓகே ஐ கோயிங் டு எக்ஸ்ட்ராபுலேட் பண்ண அப்படின்னா என்ன ஆகும் இங்க டச் ஆயிருமா இந்த பாயிண்ட் வந்து மீனிங் சி வாட் இஸ் கான்ஸ்டன்ட் ஜீரோ அப்ரோச் அப்போ இது பேர் லாம்டா எம் நாட் இல்ல ஆர் லாம்டா எம் இன்ஃபினிட்டிவ் இதுக்கு என்ன மீனிங் it means concentration near to approach zero. It means what? The limiting molar conductance illa limiting molar conductance illa the molar conductance infinite dilution. Appo in case of strong electrolyte, okay, the lambda m naught or lambda infinitive, we can find out directly to extrapolate, to extend alla, to extend illana, or we call to extrapolate the straight line, we can find out the infinite molar conductivity of the strong electrolyte. But in case of weak electrolyte, if we go the extrapolate இந்த லைன் எக்ஸ்ட்ராபுலேட் பண்ணலாம் என்ன ஆகாது இல்ல டச் ஆகாதா இது போயினே இருக்குமா டச் ஆகாது அப்ப weak electrolyte we cannot find out the limiting molar conductance using that graphical method. Okay, அப்ப we go with the indirect method. அது பேர் தான் கோல்ரஸ்லாம். ஓகேவா? By this statement please note the point. On extrapolating, on extrapolation, the extrapolation of curve, for strong electrolyte, for strong electrolyte, okay, it intercept, it is an intercept y-axis at a point which is give the value of limiting molar conductance, value of limiting molar conductance are called lambda m naught. Lambda m naught. We call what? Also called as the molar conductance. The molar conductance at infinite dilution. Important, please note. Okay, at molar conductance at infinite dilution. Okay, this is for strong electrolyte. Okay. In case of weak electrolyte, please note. In case of weak electrolyte, in case of weak electrolyte, in case of weak electrolyte, the extrapolation of curve, the extrapolation of curve does not intercept, does not intercept y-axis due to the graph the blue color, that is called hyperbolic. Okay, hyperbola graph, due to hyperbolic nature, hyperbolic nature. Therefore it cannot be calculated. Therefore cannot be calculated. Lambda m naught value of weak electrolyte. Okay. Important this note. Okay. Important piece, very, very important piece. Let's follow. Next concept. So now, either weak electrolytes. The body person, weak electrolyte. Please note. For weak electrolyte, for weak electrolyte, the increasing the lambda m due to increasing in degree of ionization, or dissociation on dilution. Okay. Now we are going to discuss, okay, the degree of dissociation using our Oswald dilution law. Okay, please note. Note the topic. The Arrhenius theory of electrolytic dissociation. Very important topic. Please note. This is Arrhenius theory of electrolytic solution. Electrolytic dissociation. Okay. No. See, take weak electrolyte. AB is a weak electrolyte. This is aqueous medium. They undergo dissociation to form A plus aqueous and B minus aqueous. Okay. According to Arrhenius theory, so according to Arrhenius theory, just wait. According to Arrhenius theory, there is an equilibrium between ionized ions, and unionized, okay, unionized molecules for weak electrolyte. This is our concept. Okay. Now, because theory teach பண்றப்பனா இந்த கான்செப்ட்ல maximum, okay, 80% to 90% they will ask only theory part தான். Okay, they will ask us a statements question. Okay, the generally பார்த்தீங்கன்னா all entrance exam they are just focusing about statement questions. Nowadays students are aspirant good in the problems, but concept is they are so weak, right? Therefore the most of examiner to set the question as a theory pattern. Okay, theory actually பார்த்தீங்கன்னா the theory question is very difficult compared to numericals. Because for numerical, we know the formula, just apply the formula, we get the answers. Okay, and in case of our theory point, we have to understand the whole concept, right, to answer the questions. Okay, but in the part one, they will ask the more number of theory questions. Okay, important, please note. Now we go with the derivation, Oswald dilution now. Simple and AB aqueous to gives equilibrium, A plus and B minus. Okay. Now see, I go direct at equilibrium. How do you happen? This is C minus C alpha. This is C alpha and C alpha. Okay. Now what is the K equilibrium? The K equilibrium equal to the concentration of A, right? C alpha. What is concentration of B? This is also C alpha. By what is concentration AB? C minus C alpha. But just wait 1 minute, just wait. Wait 1 minute. Okay. The K equilibrium, thank you. K equilibrium, C square, alpha square, take C is common, 1 minus alpha. And C cancel. Therefore, the K equilibrium equal to C alpha square by 1 minus alpha. What is the formula? The K equilibrium that equal to C alpha square by 1 minus alpha. It's the formula. Okay. Now see, we know very well for dilute solution. Please note, for dilute solution, for dilute solution, the alpha is very less than 1, right? Yeah. Therefore, the 1 minus alpha is negligible. Therefore, what is the formula? If it's acid, then I take Ka. What is Ka? The dissociation constant for acid. Okay, I take Ka. Okay, Ka. Okay, the K, we take Ka. Now, what is our C alpha square? C alpha square. Now, what is alpha is equal to? Alpha is equal to Ka by C alpha square. Therefore, finally, what is alpha? Alpha is equal to square root of Ka by C. Listen. Now, what is alpha? Alpha is the degree of dissociation. What is alpha here? Alpha is degree of dissociation. But class cut diagram, okay, take 5 minutes break and you can join. Now, time is around 5:40, okay. 5:50 you can join. Degree of dissociation. Please note. Important. Okay, this is in the concept this is called Oswald dilution law. Constant for acid. Okay, now see one more important formula, okay, in the alpha based formula. This two. What is one more important formula? We can find alpha. What is one formula? Alpha is equal to square root of K by C. Okay. What is one more formula that is called alpha? Alpha is equal to the lambda m by lambda m naught. It's a formula. What is the formula? Lambda m by lambda m. What is lambda m now? The molar conductance at given concentration. Please, what is lambda m? This is here the molar conductance. The molar. Please mute your mic. The molar conductance at a given concentration. At a given concentration. Okay. Not lambda m naught, you know. This is the molar conductance. The molar conductance at infinite dilution. Important, please note. Okay. Now you go with one question. Okay. Please note the question. The specific conductance the conductance of 0.01 molar solution of acetic acid CH3COH was 0.0166, okay, 6 Simon centimeter minus 1. Calculate the alpha value. Okay, what is given? What is given? What is a given? The lambda m naught. The value is of acetic acid. What is the value now? This is around 400 into 10 power minus 4 Simon, okay, centimeter square per mole inverse. Okay. Tell me alpha value. Anyone? Alpha value. I give you 2 minutes time. Just do it this question. Find your alpha value. Find out alpha value. Okay. What is they given? They give the specific. What is specific conductance now? Kappa they given, right? What is kappa value they given? The K equal to 0.016 Simon centimeter minus 1. What is the concentration given? C is equal to 0.01. Yes or no? Okay. Now, what is the formula? Alpha formula? The alpha is equal to lambda m by lambda m. Therefore, we are going to find lambda m based on this way. Okay. Based on this kappa value and based on this concentration, we are going to find lambda m. What is lambda m formula? The lambda m is equal to kappa into 1000. Why 1000? C centimeter square. 1000 by C. Okay. Therefore, what is the lambda m? C lambda m, what is kappa value? 0.016 by 1000. What is concentration? 0.01. Okay. What is the answer? Our lambda m is equal to 0.016 into 10 power 3 by 10 power minus 2 or plus 2 or 10 power plus 2. Therefore, lambda m is equal to 0.016 into 10 power plus 5 Simon centimeter square mole inverse. This is lambda m. Okay. What is lambda m naught? Okay, alpha பார்க்கலாம். Now what is alpha is equal to lambda m by lambda m naught. Okay. Now see what is lambda m value? 0.016 into 10 power 5 divided by, just wait, answer வருமா? 9 போயிருமா? Just wait. 400 into 10 power minus 4 plus 9 போயிடும். வெயிட், அப்போ சின்ன கரெக்ஷன் இருக்கு. அப்போ இந்த யூனிட் வராது. ஃபார்முலா கரெக்ட் தான். ஜஸ்ட் வெயிட். கவனிங்க. இதை மாத்திக்கலாம். ஓகேவா? மீட்டரா மாத்துங்க. Now get the answer. Now change the meters. Now what is the formula? Into 1000. Into 1000. Here kappa by 1000 into C. Our lambda m is equal to, what is kappa value? 0.016 divided by 1000 into 1000 into 0.01. Therefore, the lambda m is equal to 0.016 to 10 power 3 minus plus 3 10 power minus 2, therefore plus 1. For lambda m is equal to 0.016 into 10 power minus 1 Simon meter square mole inverse. This unit. Okay, now see formula. Therefore, the alpha is equal to lambda m by lambda m naught. Lambda m 0.016 into 10 power minus 1 divided by lambda m naught value. This is around what? Lambda m naught value வந்து 400 into 10 power minus 4. Okay, now what is the answer, ma? இது வந்து 1.6 into 10 power minus 3 எழுதலாமா? minus 3. இது 400 into 10 power minus 4. Now alpha is equal to 0.04.
0.04.
What is alpha is equal to 4%? It actually is a CSR question, okay? It's a CSR question, please note. No. No, we're going to discuss Oswald Debye-Huckel-Onsager here. Next topic. Debye-Huckel-Onsager theory. Okay, please note. Please note. This is a Debye-Huckel-Onsager theorem for ionic atmosphere. So Debye-Huckel theory of ionic atmosphere. Ionic atmosphere. Okay. Now, listen. If a central line is anion, okay. If central line is anion, okay. This is ionic atmosphere. Is a sphere positive sphere. Okay. Suppose if central atom is a, please mute your mic. If a central atom is a cation, what is anion sphere? It's a positive, negative. It's a negative sphere. Upper end ion central atom, the opposite sphere they're going to generate. Okay. Note the point. According to Debye-Huckel-Onsager theorem, the each ions in solution, each ion solution is surrounded by an atmosphere the atmosphere of other ions whose net charge is on the average opposite and that central atom. The central atom. It maintains the neutrality, okay? Got it. இப்போ ஜெனரலா பார்த்தோம் ஓகே இப்போ இந்த ஸ்பியர் இருக்குல்ல இப்போ ஒரு நெகட்டிவ் இருந்தா சுத்தி பாசிட்டிவ் இருக்கும் ஒரு பாசிட்டிவ் நெகட்டிவ் அது வந்து பார்த்தீங்கன்னா ஆக்சுவலா சிமெட்ரிக்கலா இருக்கும் ஓகே எப்ப சிமெட்ரிக்கலா இருக்கும்னா இஃப் யூ அப்ளை எனி எக்ஸ்டர்னல் பொட்டன்ஷியல் எக்ஸ்டர்னல் ஃபேக்டர் அஃபெக்ட் பண்ண வரைக்குமே Asymmetry தான் இருக்கும். ஓகேவா? Please note. The atmosphere is symmetrical and spherical. Very important point. The atmosphere is symmetrical and spherical. And spherical in nature. Spherical in nature. Okay. Without any external potential is applied. Without any external field. External potential or field. Now please mute your mic. Video off பண்ணுங்க please. External potential or field. Okay. Got it. This is important point. Now the Debye-Huckel-Onsager theorem. The Debye-Huckel, the Onsager theorem. Onsager theory introduce two effects. Introduce two effects. Number one, that is called asymmetric effect. Asymmetric effect. And second one is electrophoretic effect. An electrophoretic effect. Important exam point of view. Please, so this is very, very important concept. Note பண்ணுங்க. This is a very, very important concept about net exam, set exam, CSR, get any exam is important. Got it. Why we are going to study this two topic, not two effect now. Okay, this two effect can to help. Okay, I told right and dilution, whatever the molar conductivity increases how. Okay, this two effect going to explain why the molar conductivity increase or dilution. Okay, please note. The both effect. The both of this effect. Both of this effect explain why the molar conductance of strong electrolyte increases on dilution. Important, please note. First of all, asymmetric effect. First one, asymmetric effect. Asymmetric effect. Okay, now see. இப்போ இத ஒரு சென்ட்ரல் அயன் கேட்டையனா இருக்கு. இது ஒரு ஸ்பியர். ஓகே, இது அயனிக் ஸ்பியர். இப்போ இதுல வந்து I going to apply the potential. என்ன பண்றேன்? I going to ஒரு ரெண்டு எலக்ட்ரோட் வச்சிட்டு இது வந்து நெகட்டிவ் எலக்ட்ரோடு. இது பாசிட்டிவ் எலக்ட்ரோடு. ஓகேவா? Now see. இது வந்து field off. First field off. What is field off? நான் பேட்டரி ஆன் பண்ணல. அப்படியே இருக்கு. Without external potential or without external field, this ion is a spherical as well as symmetrical. Yes or no? Now I am going to on the battery. Now this electron going to act. What will happen now? Is it positive? Dot. Is sphere? Yes or no? Okay, now see. This is negative. This is positive. I told right. This central ion on the positive. அப்ப இது ஸ்பியர் நெகட்டிவா இருக்கும். therefore listen, இது வந்து the field is applied. field ஆன் பண்ணியாச்சு. இது field off. ஓகே, சாரி, இது field ஆன் இல்ல. The field off. Field off. இது வந்து field is on. Now field is on. Due to field on என்ன உங்களுக்கு is central ion going to move towards anion. Sphere வந்து central atom வந்துச்சுன்னா sphere anion அப்ப the sphere going to positive side, negative side. Okay, in the sphere actually negative side. Upper the sphere going to towards the positive end, positive terminal. The central atom will move to the negative terminal. Therefore, in apply the external field, what will happen? The spherical and symmetric nature of ion is disturbed. Okay, va? In the case now this in the positive answer in the cation. Now this cation surrounded by this anion, right? அப்ப இது எங்க மூவ் பண்ண முடியாது because of symmetrical இருக்கு spherical இருக்கு. After applying the external field, what will happen? இந்த ionic sphere இருக்குல என்ன ஆயிரும்? அது towards positive போயிடுமா? அப்ப இந்த positive ion வந்து இந்த positive central ion வந்து ரொம்ப ஃப்ரீயா இருக்கும். அப்ப you can easily move, right? அப்ப இந்த first caseல the central movement, the central ions cannot be moved fastly because of ions are surrounded. And second caseல if you apply external field, what will happen now? Now this ionic sphere going to the opposite terminal. Therefore, the central ion will be very free. It is going to move very fast. Okay, upper the conductivity increases. Other concept. Okay, please follow. The distraction of ionic sphere. The distraction. It's a distraction. The distraction. Yes or no? The distraction of ionic atmosphere. The ionic atmosphere is called asymmetric effect. Is called asymmetric effect. Okay. Now see the points. Theory important. The overall electronic environmental. The overall electronic environmental around ions. Around ions is called ionic atmosphere. Ionic atmosphere. Okay. When the external field is applied, when external field is applied, okay, the ionic sphere undergo, the ionic sphere is distracted. Very important place. Distracted. Okay. Therefore, on dilution, the distance between the charge increases. Charges increases gradually. The ionic atmosphere. The ionic atmosphere is vanish. No, vanish. Vanish. As a result, the ions move very fast. Move freely. Therefore, the molar conductance increases on dilution. Important, please don't. Okay, this is the asymmetric effect. ஓகேவா? இது வந்து பார்த்தோம்னா ஜெனரலா வந்து அயனிக் ஸ்பேஸ் சொன்னோமா, அடுத்த கான்செப்ட் வந்து எலக்ட்ரோஃபாரிக் எஃபெக்ட். அது என்ன கான்செப்ட்னா ஆக்சுவலா சொல்யூஷன் சால்வெண்ட் வந்து வாட்டரா இருக்கும். புரியுதா? செகண்ட் ஒன் அதே சேம் டிட்டோ சேம் தான். Second one. Okay, last topic today. Electro for the electrophoretic effect. Please note. இது என்னன்னா the ions in the solution, ions in the solution generally solvated. Generally solvated. Okay. Now see. இப்போ இதான் கேட்டையானா கேட்டையான். இது வாட்டர் மாலிகுல். Okay. 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 How will be atmospheric ionization on dilution? இப்போ I told right. இப்போ வந்து இது பாசிட்டிவா இது நெகட்டிவ் ஏனா சார் நோ. இப்போ what is dilution அப்படினா ions at the dilution volume increase, right? Volume increases. அப்போ வந்து இப்போ வந்து இது டிஸ்டன்ஸ் வந்து 6. ஓகே. half the dilution இது டிஸ்டன்ஸ் 6. எஸ் ஆர் நோ. அப்ப இந்த ஆனியான் இந்த கேட்டையான் டிஸ்டன்ஸ் ரொம்ப லாங்கா இருக்கு. அப்ப more dilution at the infinite dilution what will happen? This anion I mean the ionic atmosphere should be vanish ஆயிரும். புரியுதா? கான்சன்ட்ரேஷன் ஐ மீன் அந்த ஸ்பியரே இருக்காதுன்னு சொல்றேன். ஓகே. டூ ரீசன். ஒன்னு வந்து எக்ஸ்டர்னல் ஃபீல்டு. செகண்ட் ரீசன் டைலூஷன். யூ காட் தி பாயிண்ட். அப்ப ஆக்சுவலா how we are measuring conductivity அப்படினா நம்ம ஒரு கரண்ட் பாஸ் பண்ணி அந்த ions ஒரு கரண்ட் பாஸ் பண்ணி we are going to measure the conductivity of ions, right? அப்ப அந்த கரண்ட் பாஸ் பண்ணும்போது ionic sphere டிஸ்டர்ப் ஆயிரும். அது கூட சேர்த்து if you dilute பண்ணீங்க அப்படின்னா சொல்யூஷன் என்ன ஆயிரும் பாத்தீங்கன்னா அந்த ஸ்பியர் வந்து டிஸ்டன்ஸ் பிட்வீன் அந்த கேட்டையானுக்கும் அந்த கேட்டையான் சென்டர் கேட்டையானுக்கும் அந்த ஆனியான் ஸ்பியருக்கு டிஸ்டன்ஸ் ரொம்ப இன்க்ரீஸ் ஆயிரும். அப்ப அந்த கேட்டையான் ரொம்ப ஃப்ரீ ஆயிரும், ரைட்? ஃப்ரீ ஆயிரும். அது பர்టిక్యులர் அந்த இன்ஃபினைட் கான்சன்ட்ரேஷன், அது இன்ஃபினைட் டைலூஷன் என்ன ஆயிரும் பாத்தீங்கன்னா the sphere can be vanish. Sphere vanish ஆயிடுச்சு அப்படின்னா what will happen? The cation can be move very fastly. This is the vice versa for anion also. Understand? Okay. This everything, this all the things happen in the beaker. Okay, simple. Now say this is a cation surrounded by water molecule. Water molecule. Water molecule. Water molecule. இங்க H. Same concept தான். வாட்டர் இருந்தா அது எலக்ட்ரோஃபாரட்டிக். ஓகே. இது டெல்டா மைனஸ் வேணும். மைனஸ் சார்ஜ். இது பிளஸ். இது மைனஸ் பிளஸ். இது மைனஸ், இது பிளஸ், இது பிளஸ். ஓகேவா? மைனஸ், இது பிளஸ், மைனஸ். ஓகே. வாட் வில் ஹேப்பன்? இது undergo what? Solvated. இந்த கான்செப்ட் பேர் என்னது? இது solvated டாபிக். இட் இஸ் வெரி இம்பார்ட்டன்ட். ஓகே. இது கேட்டையானுக்கு. இன் கேஸ் ஆனியான் சிமிலர் அதே மாதிரி. இது ஆனியான். இது வாட்டர் மாலிகுல். இங்க H, 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 இங்க H. இது டாட் 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 டாட். ஏன் இது பிளஸ், இது பிளஸ், இது பிளஸ், இது பிளஸ், இது மைனஸ், மைனஸ், மைனஸ். ஓகே. அதான் பார்ஷியல் சார்ஜ் இருக்கு. அண்டர்ஸ்டாண்ட்? சரி. ஓகே. இது ஜெனரலா இருக்குமா? அதே கான்செப்ட். ஓகே. அதே கான்செப்ட் தான். Now the electric field going to apply it. Same concept தான். And applying electric field. இது என்ன கான்செப்ட்? இப்போ நீ லிசன். லாஸ்ட் இதுலயும் அயனிக் ஸ்பியர், இதுவும் அயனிக் ஸ்பியர் தான். இந்த 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 அயனிக் ஸ்பியர் ஆக்சுவலா சால்வெண்ட். ஓகே. வாட்டர் மாலிகுல். ப்ளீஸ் நோட் the ionic sphere also the ionic sphere, the ionic atmosphere, the ionic atmosphere are also solvated. Okay. நம்ம ஃபர்ஸ்ட் கேஸ்ல ஜெனரலா ஸ்பியர்னு பேசணும். இங்க அது வாட்டர் மாலிகுல். ஓகே. சால்வேட்டட். சேம் இது. ஓகே. If on applying the external potential, on applying the electric field, they move opposite direction. Okay. Therefore, the central ion can move freely. Same concept. Ditto எல்லாம் same தான், ஓகேவா? அப்ப என்ன சொல்ல வராங்க அப்படின்னா, ஓகே ஃபர்ஸ்ட் வந்து if you apply the external potential, ஓகே the symmetrical sphere going distract ஆயிரும். ஓகே அப்ப அயான்ஸ் வந்து பாத்தீங்கன்னா ஓகே ரேண்டமா மூவ் ஆகும். வித் டைலூஷன் என்ன ஆகும் பாத்தீங்கன்னா அந்த 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 ஸ்பியருக்கும் அந்த சென்ட்ரல் ஆட்டத்துக்கு உள்ள அந்த அட்ராக்ஷன் வந்து வேனிஷ் ஆயிரும். இட் மீன்ஸ் the sphere going to vanish. இப்போ ஸ்பியர் வேனிஷ் ஆயிடுச்சு அப்படின்னா அங்க வேற சரௌண்டிங் ஆட் எதுவுமே இருக்காது. that ion going to move very easily. Okay, see the final point I give again one more, please note. Very important point. What is important now? On dilution, the distance between ions increases gradually. The ionic atmosphere vanished as a result. These ions move more freely. Just wait. Ions move very freely. Therefore, the molar conductance increases. Yeah. Now, what is the equation? Debye-Huckel, please note. The equation called Debye-Huckel-Onsager equation. Please note this equation. Lambda m equal to lambda m naught minus a plus b இங்க lambda naught m இங்க root c. இதான் formula. But please listen. This formula only for strong electrolyte. Okay. இதுல பாத்தீங்கன்னா a b இருக்கு. lambda m you know what is lambda m னா molar conductance. lambda infinite what is lambda naught அப்படினா infinite molar conductance. see இப்போ formula now see if நான் வச்சுக்கோ இப்போ c approach to 0 என்ன ஆயிரும் இந்த term ஃபுல்லா 0 ஆயிருமா இந்த term ஃபுல்லா 0 ஆயிடுச்சுனா அப்ப c approach 0 என்ன மீனிங் that is limiting molar conductance. therefore இந்த கேஸ்ல the lambda m equal lambda m naught. they will ask okay எந்த கண்டிஷன்ல lambda m lambda infinity சேமா இருக்குமோ எப்ப when c is approach to 0. okay இதுல where a b are constant. But please note. Okay, அப்ப c increases, concentration increases, lambda m decreases. dilution volume increases, concentration decreases. yes or no? அப்ப concentration increase ஆனா lambda m decrease ஆயிடும். அப்ப more concentration ல less conductivity. ஓகேவா? this about today class. Next week going to discuss Faraday's law and electrolysis product. ஓகேவா? Any doubt? Okay, Colress law இருக்கு. Next week I think we have 2 classes on Saturday Sunday. ஓகேவா? Any doubt you can ask one by one. But regarding test, okay, I am little bit busy. I will make sure within this week we are going to either revision test. Okay, like test portion சொல்லிருந்தேன். Because of tight schedule, I cannot able to make a question ready பண்ணியாச்சு, but I cannot able to type the questions. Okay, because I plan to conduct the online test in Vijay Chemistry app. Okay, the revision test வந்து பாத்தீங்கன்னா within this week I am going to conduct. I will announce the date, exam date. Okay, you continue the preparation. Any doubts?
Sir,
Yes, ma'am.
Sir, variation of molar conductance with dilution and dilution K decreases ன்னு சொல்லி ஒரு கான்செப்ட் சொன்னீங்களா சார்? அத
Yes,
மட்டும்
ma'am.
இன்னொரு டைம் சொல்ல முடியுமா சார்?
Okay. இதுவா மேம்?
Yes.
On dilution, we know right, conductivity decreases. Dilution, conductivity decreases. Okay, well. At the same time, concentration also decreases, right? Opposite lambda m depend upon K as well as 1 by m. Yes, sir, it's 1 by m. We can consider 1 by m. Okay, but lambda m dilution to K as well as lambda m dilution 1 by m. Upon dilution, please note, on dilution, just wait. On dilution, K value decreases. M value also decreases. But 1 by m value increases. Yes or no? 1 by m value increases. Now see the discussion. The lambda m dilution to m, dilution to K. At the same time, lambda m dilution 1 by m also. But dilution பண்ணும்போது K decrease ஆகுது. At the same time, 1 by m value increase ஆகுது. அப்ப இந்த lambda value வந்து இந்த lambda value depend upon K as well as 1 by m. அப்ப K பொறுத்து இருந்துச்சுன்னா lambda m decrease ஆயிரும். 1 by m பொறுத்து இருந்துச்சுன்னா lambda m increase ஆயிரும். Experimentல பாத்தீங்கன்னா which is more dominant factor னா 1 by m more dominant factor compared to K value. அப்ப அந்த dilution, the 1 by m value it increases. Therefore, 1 by m value decreases as compared to decreasing K value. புரியுதா? அப்ப இந்த வேல்யூ இன்க்ரீஸ் ஆகுதுல, அதோட இந்த K value decrease கம்மி தான். அப்போ conductivity depends upon molar conductance depends upon only 1 by m தான், not kappa value. அதனால on dilution 1 by m increases, therefore lambda m also increases. You got the point? This is experimental investigation. Okay. Listen, one more students asked
Okay.
out, what is the conductance,
kappa
what is the
value
molar
ங்கிறது வந்து
conductance? Yes, ma'am.
கப்பா அப்படிங்கிறது 1 யூனிட் செல்ல வந்து கண்டக்டிவிட்டி பாக்குறது, 1 by m அப்படிங்கிறது பெர் மோலார்
Concentration தான், simple. Molarity. M is இப்ப இந்த K will depend upon lambda will depend upon K as well as 1 by m according to formula. Okay.
எஸ் சார்.
அப்போ on dilution K, we know K value conductivity decreases. M value decreases தான், ஆனா 1 by m value increasesல. அப்ப lambda value depend upon K as well as 1 by m. ஆனா ஒரு ஃபேக்டர் டிக்ரீஸ் ஆகுது, ஒரு ஃபேக்டர் இன்க்ரீஸ் ஆகுது. Experimentally what they find out na, compared to K factor oda 1 by m factors are more dominated. அப்ப 1 by m factor எப்படி இருக்கோ அதை பொறுத்து lambda m இருக்கும். அப்ப on dilution 1 by m factor increase ஆகுது, அதனால lambda m increase ஆகுது. Suppose அந்த ப்ராப்பர்ட்டி கப்பல் பொறுத்து இருந்துச்சு டிக்ரீஸ் ஆயிருக்கும். எக்ஸ்பெரிமெண்ட் பாத்தீங்கன்னா the lambda m factor depends upon only 1 by m factor, not kappa factor. Understand?
Thank you sir.
Okay, what is called conduction conductivity? Conduction is a property. Listen, conductance and the G. Conductance na G, in the G, conductance. Okay, conductivity na kappa. Conductivity na kappa. Okay, this is conductance. This is conductivity. Conduction is a process. Okay. Any other doubts? Any other doubts?
Specific conductance
Yes, ma'am.
decreases னு ஒரு இடத்துல சொல்லிருக்கீங்க. இதுக்கு முன்னாடி சார் அந்த both சார் அந்த variations of conductivity and molar conductance with dilution இருக்குங்க சார் அந்த டாபிக்.
Yes, ma'am.
ஃபர்ஸ்ட் டாபிக்.
Yes,
அதுல
ma'am.
வந்து both அதுல both ஆமாங்க சார்.
இவனை change பண்ணிட்டேன் அது. Both conductance conductivity change in both time, not decreases.
இல்லைங்க சார் அந்த ஆமாங்க சார் அது both kappa
Change.
and
Both kappa and
change
lambda
with
m change with dilution. Change with dilution. It can be increases, it can be decreases. Now explain, right? K value always decreases. or dilution. Lambda m value always increases with dilution. Conductivity for 1 centimeter cube.
இல்லைங்க சார் டைல்யூஷன்ல வந்து ஸ்பெசிபிக் கண்டக்டன்ஸ் இன்க்ரீசஸ் தானுங்க சார்
Specific conductance means conductivity decreases, ma'am.
கண்டக்டிவிட்டி ஆர் ஸ்பெசிபிக் கண்டக்டன்ஸ் டிக்ரீசஸ்
It decreases.
Specific conductance.
Decreases lambda m.
மோலார் கண்டக்டன்ஸ்ல தான் இன்க்ரீசஸ்
Yes, ma'am, increases.
ஓகேங்க
Because specific conductance now specific means we are going to fix a standard condition. Okay, that means 1 centimeter cube. Upon the 1 centimeter cube with discuss பண்ணா அப்படின்னா decrease ஆயிரும். Whole system increase discuss பண்ணா increase ஆகும். That's a minor difference versus conductivity and molar conductance. Any other doubts?
ஓகேங்க
Okay. Thank you and see you next week and take care. Tata, bye bye.
Excuse me, sir.